Okay, so today we are doing trig formulas, and these are, first of all, I should just say off the bat, you do not have to memorize these formulas, but you do have to know your certain angle measures by heart, right? And our angle measures that we know by heart are like 0 degrees, 30 degrees, 45, 60, 90, ... right? We know our 16 unit circle angle measures by heart. So if we want to find the sine of a 75-degree angle, that's not one of our unit circle angles, but we can create 75 by adding together two angles we know. We know 45 and we know 30. So if I rewrite sine of 75 as sine of 45 plus 30, you'll recognize that that's going to go with this formula. The alpha being 45 and the beta being 30. So if I just plug it in, I'm going to get sine 45 cos 30 plus cos 45 sine 30. And these I know, right? Sine of 45, root 2 over 2, cos of 30, root 3 over 2. Cos of 45 is root 2 over 2, and of course sine of 30 is a half. So if I kind of simplify that, do you agree that I get root 6 plus root 2 all over 4? You are right. And that is the exact answer for the sine of a 75. If I want to do the cos of a 105, so now I'm going to come up with two angles that I already know that add up to 105, and you are right, 60 plus 45. So now I'll use this formula, alpha being 60, beta being 45. So this would be cos 60, cos 45, plus sine 60, sine 45. Cos of 60, root 3 over 2. Oops, nope, cos of 60, sorry, a half. Root 2 over 2. Sine of 60, root 3 over 2, and then root 2 over 2. So again, if we kind of clean that up a little bit, root 2 plus root 6 all over 4. You can think about that like, wait, wasn't that just the same answer as sine of 75? Why would sine of 75 be the same as cos of 105? Well, that's right. They're both the 75-degree reference angle, right? So those would be the same. Sine of 165, again, I'm going to come up with two angles. And there could be more than one answer, but I would think 120 plus 45. If you had a different combination of numbers that add up, those work as well. It would give you an equivalent answer. Sine of 120, so I'm going to put this in my first formula, sine 120 cos 45 plus cos 120 sine 45. Sine of 120, so that's the 60-degree reference in the second quadrant, so that's going to be positive root 3 over 2. And then this is root 2 over 2 plus cos of 120 is now negative a half and root 2 over 2. And again, we'll clean that up, so it'd be root 6 minus root 2 all over 4. Here we go. Next one, we got our difference formulas. So if you look at them, you might be like, kind of looks like the sum formula, right? Where this one had a plus here and a plus here in the sum formula, this has a minus and a minus. And similarly, where this cosine one had a plus and then a minus, now we have a minus and then a plus. But you don't have to memorize these formulas, so that makes life a lot easier, doesn't it? Sine of 15, I'm going to rewrite as the sine of 45 minus 30. Now you could do 60 minus 45. That would work too. It would give you an equivalent answer. I'm still going to show my work, right? So I'm still going to write out sine 45 cos 30. Now it's minus cos 45 sine 30. Sine 45, root 2 over 2, cos of 30, root 3 over 2, then I got another root 2 over 2, and a 1/2. So when I clean that up, it's going to be root 6 minus root 3 all over 4. And again, I'm sorry, it's the first time I'm using this stylus. I probably need to get another one. Let's see if I try it this way. So here, let's see, we've got cos of 15. So again, I'm going to use 45 minus 30. 45 minus 30. I'm going to use my cos formulas. Now, as you go with this, the temptation is to just not show the work, right? And just do it in your head, but I would always show the work. Cos 45, cos 30, plus sine 45, sine 30. Cos 45, root 2 over 2. Cos 30, of course, root 3 over 2, plus root 2 over 2, and a half. So this is going to be root 6 plus root 2 all over 4. And we get a lot of similar looking answers for all of these. I got to think for a second. 245, would that be 270 minus 45? I think so. So this would be cos of 270 minus 45. So this is going to be cos 270 cos 45 plus sine 270 sine 45. That was a minus up there, so this would be sine 270 sine 45. Cos of a 270, of course, is 0, so that makes life easier. Sine of a 270 is negative 1 root 2 over 2, so it's negative root 2 over 2 is the cos of a 245. Is that right? 270, yeah. Okay, and then the last things here are just some little extra questions. We use our sum or difference properties to prove. So it's back like our identities. So I'm going to take that first formula, and pi over 2 is 90. So if you want to write it as 90, you can. This would be sine 90 cos theta plus sine, cosine, cosine, sine, right? Cos 90 sine theta. Sine of 90, of course, is 1, so I have 1 times cos theta plus cos of 90 is 0 times sine theta. So if I simplify that, I get cos theta, which matches. Similarly here, and you could put this if you wanted to, although you don't have to. You're probably going to need the extra room. 3 pi over 2 is a 270, so this is cos 270 cos theta plus sine 270 sine theta. Cos of a 270, of course, is 0, so 0 times cos theta. Sine of a 270 is negative 1 times sine theta, so negative sine theta. Done and done. Last one here, of course, pi is 180, so this would be cos 180 cos x plus sine 180 sine x. Cos of 180 is negative 1, so I have negative 1 cos x. Sine of 180 is 0, 0 times sine x, and I end up with negative cos x. So you're basically just putting in the formula and simplifying to get the other side. The last one is a solve, right? So the last one, this one is going to say, between 0 and 360 when we're all said and done. So I'm just going to plug them in. So let's see, the sine formula would be sine x cos, I'm going to write that as a 45, right? Plus cos x sine 45. So that's kind of this one here. Then here, maybe I'll change colors. If I do this one, this would be cos x cos 45 plus sine x sine 45. And this is equal to 0. Well, I think I have some things that cancel out, or no? Let's see. I don't know, I think I got to figure it out. So sine x cos 45, so this will be root 2 over 2 sine x. And then this will be, of course, root 2 over 2 cos x plus root 2 over 2 cos x plus root 2 over 2 sine x. And that's all going to equal 0. So if I combine my like terms, like root 2 over 2 sine x, root 2 over 2 sine x, I'm going to get 2 root 2 over 2 sine x, or just root 2 sine x. Similarly here, I'm going to add this up to root 2 cos x, and this is going to equal 0. Because it's an equation, I can divide everything by root 2, right? So sine x plus cos x equals 0. So the sine x is equal to the negative of cos x. So we've done this before. We think on the whole circle, where are angles where the sine is and cosine are equal but opposite signs, positive and negative, and that's going to be at 135 degrees and 315 degrees. Ta-da!